Yeah, let us see the main lecture, that is iGCSE chemistry on physical chemistry. That is, the topic is acids, alkalis, and salts. In this, I'll describe the use of indicators litmus, phenolphthalein, and methyl orange, and to distinguish between acidic and alkaline solutions. To understand how the pH scale to form 0 to 14 can be used to classify solutions to strongly acidic, weakly acidic, and natural, weakly alkaline, or strongly alkaline. And also in this session, I will describe the use of universal indicators to measure approximate pH value of solutions and define acids as solutions, sources of hydrogen ions, and alkalis as sources of hydroxide ions, and predict the products of reactions between dilute hydrochloric, nitric, and sulfuric acids, and metals, metal oxides, and metal carbonates, including the reactions between nitric and metals, nitric acid and metals. In this session, we will understand the general rules of predicting solubility of salts in water. All the common sodium, potassium, aluminum salts are soluble in, and all nitrates are soluble, and common chlorides are soluble except silver chloride. All these things we'll learn. Along with the common sulfates are soluble except those barium and calcium in this session. And finally, we will describe the experiments to prepare soluble salts and from acids, and describing experiments to prepare insoluble salts using precipitation reactions. And finally, in this session, we will describe the experiments to carry out acid alkali titrations. Let us see pH scale and indicators. pH scale is a measure of how acidic and alkaline solution is. Acidic means pH is in between 1 to 7. Very low pH value is 1, high pH value is 6. And if it is 7, it's neutral. From 8 to 14, it is alkaline. Slightly alkaline, pH value is 8. Very strongly alkaline, pH is 14. Here, all substance forms an aqueous solution when it dissolves in water. Water itself is neutral. When substances dissolve in water, they dissociates into individual ions. Water dissociates into H plus aqueous and OH minus aqueous. H plus is hydrogen ion, OH minus is hydroxide ion. H plus is acid, hydroxide ion is alkali. Indicators are special dyes that change color according to whether they are in acidic, alkaline, or neutral solutions. So pH scale and indicators concept in the indicators are most important. Three common indicators are litmus, phenolphthalein, methyl orange. Litmus, acidic and alkaline, in between that strongly alkaline, the blue litmus converts into red. Alkaline is 8 is there, then it converts into blue litmus. Red converts into blue. Methyl orange indicator. See slightly how 4.4 to 6.2 we have shown. So what is the indicator color and all we are observing. Like with strongly alkaline means pink color will come. 8.3 to 10. Universal indicator is a mixture of dyes and shows a complete color range across pH scale. Strong acids, weak acids. Strong acids pH is less, weak acids pH is more. And weak alkalis or pH is less, strong alkali pH is more. Between 8 to 14. 14 is the number of pH for an alkali that is called strong alkali. Hydrochloric acid formula HCl, sulfuric acid formula H2SO4, nitric acid formula HNO3, acids. Alkalis, sodium hydroxide, it is NaOH, potassium hydroxide, it is KOH, calcium hydroxide, it is KCaOH. These are actually common acids and alkalis. Now, salt formation. When acids and alkalis react together, salts are formed. The general equation is acid plus base gives salt plus water. This is known as neutralization reaction because the products are neutral. Salt formation. In this, salts consist of two parts, a metal part and a non-metallic ionic form, a part that is acid. Hydrochloric acid, ions in solution H plus and Cl minus. Salts formed are chlorides. Sulfuric acid, ions in solution H plus ions and sulfate ions. Salts formed are sulfates. Nitric acid, ions in solution H plus and NO3 minus nitrate ions, and salts formed are nitrates. Example salts: copper sulfate, CuSO4, metal ion, Cu2 plus, non-metal ion, SO4 2 minus, sodium chloride, NaCl, metal ion is Na plus and non-metal ion is Cl minus. Potassium nitrate, KNO3, in this metal ion is K plus and non-metal ion is NO3 minus. Calcium sulfate, that is formula CaSO4 and metal ion is Ca2 plus, non-metal ion is SO4 2 minus sulfate. Acid plus metal, what will happen? Salt plus hydrogen will come. A reaction of salts in this, an acid reacts with metal, means salt plus hydrogen will come. Magnesium with hydrochloric acid gives magnesium chloride and hydrogen is the best example for this one. Acids plus metal, have you got that? Are you really sure? Let's try a few examples. Acid plus metal, magnesium plus sulfuric acid. Magnesium sulfate will come with hydrogen. Iron plus hydrochloric acid, iron chloride and hydrogen. Likewise, lead plus sulfuric acid, lead sulfate and hydrogen. Acids plus metal oxides, acid plus metal oxide is salt plus water. Copper oxide plus sulfuric acid, copper sulfate plus water, CuO plus H2SO4, CuSO4 plus H2O. Now, acid plus metal oxides, have you got that? Are you really sure? Let's try a few examples. Acids plus metal oxides, magnesium plus hydrochloric acid, magnesium chloride plus water, iron sulfuric acid, iron sulfuric acid oxide, iron oxide plus sulfuric acid, iron sulfate plus water, lead oxide plus hydrochloric acid, lead chloride plus water. Acids plus metal carbonates. Acid plus metal carbonate gives salt plus carbon dioxide plus water. Here, if you take copper carbonate with HCl, copper chloride with CO2 and H2O. Guess that what? That's right? No. For examples, more examples. If substances is soluble, then this means that will dissolve in solvent. The most common solvent you will come across is water. Solute, the solid, plus solvent, the water gives solution, aqueous. There is no easy way around this. You're just got to learn the relative solubility of salts. Solubility of salts. All ammonium, potassium, and sodium salts are soluble in water. All nitrates are soluble in water. Most chlorides are soluble in water except lead and silver. Lead chloride is soluble in hot water. Most sulfates are soluble in water except barium and calcium and lead. Most carbonates are soluble in water except sodium, potassium, and ammonium. Carbonates are insoluble in water. Preparing soluble salts from acids. Preparing insoluble salts using precipitation reactions. Reactions carry out acid-alkali titrations. Preparing soluble salts from acids, we'll see. The preparation of sodium chloride by neutralization. We'll take dilute sodium hydroxide plus an indicator, dilute hydrochloric acid, both will be added, and we'll get a solution that is called sodium chloride solution with pH exactly 7. The preparation of sodium chloride by neutralization is decolorizing the charcoal and filtrating that one, evaporating the basin. Crystals of sodium chloride forming, and this is the filtrate and steam, water bath, Bunsen flame will be taken to heat all these things. So acid plus alkali, salt, alkali gives salt plus water, HCl plus NaOH gives NaCl and water. So we will take sodium chloride crystals in this reaction. Next, preparation of lead iodide. Lead nitrate and lead iodide, if you take, the yellow precipitate of lead iodide will be formed and that will be filtered. So the filter to separate the precipitate and wash it with distilled water and try to get pure product. That is PBI. Salt plus salt, lead nitrate plus lead iodide gives lead iodide plus potassium nitrate, double displacement reaction. Acid-alkali titrations. A titration is very accurate way of adding an acid to an alkali to get salt. To carry out an acid-alkali titration, we need the right bits of kits. One is conical flask. This looks a device that is called conical flask. Next, this is pipette. This is burette. So we will use these three main important devices, kits. Next, we'll see acid-alkali titration, stage 1. In stage 1, if you see the meniscus, up to that we will take the liquid, that is dilute sodium hydroxide in this with the help of pipette. The solution is sucked up into a pipette using pipette filler, and the pipette containing exactly 25 centimeter cube of solution. When the bottom of the meniscus is level is with the pipette mark is coincides, then that is the exact measurement. The sodium hydroxide solution is then released into the conical flask. This is meniscus and its observation. Next stage is 2 or 3 drops of an acid or alkali indicator, acid-alkali indicator, such as litmus solution, are added to the sodium hydroxide solution using to treat pipette solution. This is a teat pipette and the alkali turns litmus blue. The burette is filled with burette hydrochloric acid, dilute hydrochloric acid to get zero reading. Again, look for the meniscus here. So the conical flask is placed on a white tile beneath the burette. Acid is added from the burette until the color of the solution turns from blue to red. The point at which the color changes is called end point. At this stage, the conical flask only contains salt and water. At the end of the volume, at the end point, the volume of acid added can be measured by reading of the volume used in the burette. This is the titer. So preparing soluble salts from acids, we have understand next. Preparing insoluble salts using precipitation reactions. Carrying out acid-alkali titrations. So this is the end of this session. In this session, we have covered pH scale and indicators, common acid and alkalis, salt formation and reactions, preparing salts. Thank you.